Good morning, everyone. I hope you are well and healthy, and I hope you remember that time dilation was one of the last ideas that was mentioned in the previous video, and this is what I'm going to talk about. And I'd like you to please make sure you know how to derive the time dilation formula at the end of this video. Okay. So we know that in Einstein's interpretation of the Michelson-Morley experiment, the speed of the observer does not affect the measured speed of light. And mathematically, what this means is that any value added or subtracted from c will leave it unchanged. And from these equations, we can conclude that the universe has a speed limit, or light has no frame of reference, or anything in the universe is a frame of reference for light, and the speed of light is absolute. Now, if you read these statements carefully, if you think about them, you're going to see that all these statements are equivalent. They all mean the same thing. And the special theory of relativity is a collection of ideas that studies the implications of these statements. And this is what we're going to discuss next. Okay? And now, let us consider two events that take place at the same time, and I'm going to use my pen to describe the two events. Okay? Now, the first event is consists of a photon traveling vertically between the two ends of my pen. I'm going to call this point at the bottom point A. I'm going to call this point point B. So this is the first event. Remember that the photon travels with the speed of light. The photon is a particle of light. And now I'm going to look at the second event. And the second event consists of the pen translating horizontally in front of you. So the pen moves horizontally from left to right on your screen. And I'm going to call this point, this was point B originally in the first event, and this is going to be point B prime. Okay, and please remember that these two events happen simultaneously at the same time. It's important to remember for the purpose of our discussion that any event has a duration, has an extension in time, and I'm going to use t instead of delta t, and I'm going to use a t prime instead of delta t prime, but they mean the same thing. Okay, and now I'd like us to see a representation of these two events. So please try and see if you can make sense of this diagram. And here you have the photon moving vertically, and here you have the pen moving horizontally. And you can clearly see that this situation resembles our dog crossing the river problem. And you probably recognize that since the photon is moving in two directions at the same time, the velocity along the hypotenuse should be larger than the velocity of the photon. But it isn't. And the question is why? And the answer to this question would be because c represents the speed limit in this universe. The speed of the photon is the largest speed information can travel with in this universe. And now the only explanation for this phenomenon would be that when the pen translates horizontally, the photon is experiencing a different rate of flow of time along this direction. Okay? Now, the time dilation formula represents the relationship between the two speeds of flow of time, and this is what I would like you to try and derive. Please spend some time deriving this formula. You're going to see that all you have to do is use the geometry of this right triangle and then express the ratio between t and t prime, and you're going to get this value at the denominator. This is what we call the relativistic factor. Um, and I will also ask you to think about the meanings of this formula. And this is what we're going to discuss next time. I'd like you to please go over the relativity of simultaneity, and I'd like you to see if you can spend a little time trying to understand what the paradox of the time dilation formula is. This is what we're going to discuss in the future as well, and I'd like you to please go over the twin paradox. Um, um, if you have a little time. Okay. Now, thank you um, very much for watching, and I hope you will see me again soon. Thank you.